Thank you. Hello, everyone. My name is Miguel Beltran, and I'm a freelance software developer. And today I will be talking about testing with Flutter. My Twitter handle is MIBLT, and my website is beltran.work. I do specialize in mobile development, mainly Android and Flutter. For the last 2 years, I've been working on more Flutter projects than Android projects, and that trend, as a freelancer, seems to be going that way. I'm also the co-host of a podcast called Code Cafeteria, where we talk about developer life, tech games, and other things. And of course, you can reach me out on my website. There's my email address, and also you will find there a contact form. Today, I will talk about testing in Flutter with 3 different approaches: pure Dart, Flutter widgets, and also running driver tests on real devices. You will also learn how to use mocks and fakes on Dart. I will show you why the architecture that you choose on your app will make it easier or harder to test, including decisions on state management and on dependency injection. And finally, we will look at some of the limitations on testing on Flutter and how we can handle them. To learn about tests, I'm going to use a small, simple app called GIF Review. This app has a very simple purpose, which is to let users rate GIFs by giving them a score. It contains 2 basic screens, one that displays the list of GIFs and one that displays the list of individual ratings. Users can also submit their rating by tapping on the stars. And all the code that you will see here today is also available on this GitHub repo that you see on the screen. Let's start with this question. Why do we need to test at all? Actually, it's a very complicated question because there's always a balance between going fast and having reliable code. And this is a quote from the Flutter documentation. The more features your app has, the harder it is to test manually. Automated tests help ensure that your app performs correctly before you publish it, while retaining your feature and bug fix velocity. And I think that this last sentence is important. With Flutter, you will see that the speed of development is not only on things like writing once and running on 2 or more platforms, but also on the speed of writing and running tests. In Flutter, we have 3 different types of tests. We have Dart tests, which are pure tests that don't depend on Flutter, that run very fast and are also very easy to write. Then we have widget tests, which are also very fast, which allow you to test widgets directly without running on a device. And again, important, you don't need a real device here to run a widget test. And finally, driver tests, which are indeed running on a real device. And by device, it could be also a desktop computer or a mobile phone, or even a website is also a device. Let's start learning a little bit more about Dart tests by writing one. So let's take a simple Dart function from the app. This is a function that calculates the average of a list of ratings and returns it as a double. The actual content of the function doesn't really matter here. What matters is that this is a pure function with no external dependencies, takes one input and outputs a result. So we're going to start by creating a new Dart file inside the test folder. And we will add first a main method declaration into this file. And inside this main method, we will add our first test. In the description, I wrote calculate ratings. And as the second parameter, we have a callback. And this is the body of your test. This is actually different to the way we used to write tests in Java or Kotlin, where we create methods that we annotate with test. Here, the test run inside callbacks on this test method. Then let's write the body. And well, we see different things here. First, notice that we can actually have test code outside our test callback. And if I'm gonna reuse this ratings array, for example, with other tests, I can put it inside the main function declaration or even outside of this main call and just use it from my test. There is no obligation to have that inside. And then we call to calculate average method inside the callback. we get the average and we check that this average is 4. So for that, we use the expect method. You're going to be using expect a lot when testing in Dart and Flutter. This performs an assertion that the actual matches the matcher, meaning that it will fail the test if they are different. The cool thing is that the matcher can be both a value or also a matcher that is provided by the test library. Expect takes care of wrapping values and matchers for us. So if we pass here just a 4, is the same as calling expect with equals 4. There is no reason to be verbose here, you can just call with 4. Some examples of matchers are is not empty, which is used for arrays, finds one widget, which is used for widget tests, and we will see it in a moment, or also is true, that checks that, well, a Boolean is true, but you can also just write true there and it will work. You can run the test either by clicking on the green play icon that will appear on Android Studio on IntelliJ, also by clicking or right-click and opening the menu and then selecting Run Test If, or you can run all tests in the project via command line with just Flutter test. And well, this concludes the super short introduction to Dart tests. You have seen what is a basic Dart, pure Dart test that tested a single pure Dart function, and now we're going to look into the interesting part, which is the widget test. Here we have a widget from the app, and this is a GIF score widget is called. This widget takes a GIF object and displays it, showing the title as in a text widget. The image, which is from a URL, is displayed in an image network widget, and it also uses a custom widget called the Smooth Star Rating to display the rating. For this test, I will just be focusing on the text. So this is a detail of the widget implementation. As you can see, the widget takes a GIF object as a parameter and then builds the widget and displays it. So what we need to do in our test is also to pass a GIF here, display it, and verify that the text that is displayed is the one that we expect. To write a widget test, we use instead the test widget function rather than the test function. We can also have a description here, and we have also a callback, but you see a clear difference here. And the difference is that we have a parameter in our callback, which is this widget tester. We're going to use this widget tester for many things, from loading the widget to also performing tabs and to writing text into them. In the test, we load the widget on the widget tester, in this case, the GIF score, and that we want to test using the pump method. We pass a hardcode GIF object, which is the one that we want to display, and we're going to be using for testing. And we want to check that the title is indeed being displayed. So I will just run this and see what happens. And we see that we face an error already. And when we take a look at the logs, we see that it complains with an error that says that the text directionality is missing. So we can fix this issue by wrapping our widget inside the test with the directionality widget and then providing the text direction. We don't usually do that in our code because the material app widget is already providing that for us. It's already providing directionality for us, but here we need to provide it manually. And this is the normal way of testing things in Flutter and testing widgets. Sometimes you need to provide other widgets around them so they will work correctly when running tests. Finally, we also add our expect condition. And as you can see, we use the same expect as with Dart tests. But here we provide a matcher that tells us that we should find one widget. Find.text is the finder, and we'll look for any widget that has this text on it. There are other types of finders. For example, by key is the most common one, which allows you to find widgets by a defined key. By semantics label is one of my favorites. It uses the semantics tree, which is what the screen readers are using to find widgets, so you can use it together with your accessibility code. Descendant allows you to search for widgets that are the child of another widget that you're using a finder to find. So for the record, and this is very short, here's the complete test that loads a single widget with a GIF object that checks that the title and then checks that the title is displayed correctly. And you may notice that I also have here something called mock network images for. We will talk about that at the end of the talk because it's important, but for now you will have to wait. So this concludes the super short introduction to widget tests. Let's move into driver tests. Driver tests work in a completely different way than widget tests. In this case, we are running the test on a real device, and we will have some external code that is controlling this device, kind of like a real user touching and using the app. We're going to test our full app. The test will start the app, and it should display the screen that you see here. Then we're going to verify that the title text is displayed on the screen for the first GIF. This means that we need to compile and run the app each time that we run the test. And as you can figure out, that's a bit more work than what we have done so far. In the current stable version of Flutter, in version 122, only Android and iOS projects are supported by default. However, in the Flutter beta, we can run also these tests on a desktop application or on a website, so in a browser, and run our tests there. This will speed up a lot the compilation time and also will improve the usage of resources. The setup process is not too complex, but it requires some extra steps compared to the previous ones. For the specific details, look at the official documentation. Now that we have added the Flutter driver dependency in our project, we need to create a series of test files, and we can start with two of them, the app and the app test. App contains a main function that calls our original main function from the app code, but it also calls to enable Flutter driver extension. Basically, what we are doing by calling this function is to give access to Flutter driver to control our app, including doing stuff like using the keyboard or editing text. The tests instead go into app test file. We also see some differences here. First, we need to connect to Flutter driver before starting our tests, and then we also need to disconnect at the end. Tests look very similar to Dart test, in which we use the test method and we use the driver instance to find widgets and interact with them. Kind of similar of how we interacted with the Flutter widget tests. And the API is also similar, but it's not the same, but it's similar. Here I use the find by value key to find the GIF widget, and then descendant to find the title inside the GIF widget. So to run this, it is a little bit more complex, and we need to go to the terminal to do it. Here we have the Flutter driver command, in which we specify the target that we want to run, which is not app test, but is the app.dart. This takes care of launching the app and running the test. But again, something went wrong. It says get text is taking a long time to complete. So if we wait here 30 seconds, what we end up seeing is this. It looks like that I made a mistake. The ID of the widget is not GIF score, but is GIF score 1. But I didn't see any relevant error on the screen. Why? We see that it shows the driver error, failed to fulfill get text due to remote error. And that's it. Well, that's bad because it doesn't really explain what's the problem. When we do widget tests, these type of errors are quickly detected. A missing ID is something that the test will have warned explicitly saying that no widget exists with that ID. However, here we get a different message, a little bit more confusing. We fix it and we run again, and now, well, it runs really fast, of course, and then it works and it finishes. So we can learn many things here. Driver tests are a bit more complex to set up. They require a real device, which can also be an emulator, and they are hard to debug when things go wrong, as you have seen. However, they are the only type of test that really emulate a real user. A quick summary of the three options. In terms of speed, both Dart and widgets are quick, while driver tests take a while to run because they cannot run in parallel and we need to compile the app to run them. In terms of stability, we see that both Dart and widget are very stable, while driver tests will be a bit more unreliable because they depend on the device, the state of the app, etc. In terms of coding, writing Dart test is the easiest one. Widget test can get complicated, to be honest, and driver test is way more complicated than the other ones. And in terms of representing the real user, Dart tests don't really do that. You cannot have user interaction in them. Widget tests are somehow closer because you can have interaction here, but they don't represent the full experience. And driver tests are the closest to the real user that you can be, besides while doing manual testing. So you have learned so far the three main ways a Flutter developer can write tests. Let's see how we can do better now. I think that the biggest issue developers face when writing tests is not that the tests are hard to write, but that the code is hard to test. So here I will share some tips on how you can make your code easier to test. So far we have tested code that didn't have any internal dependencies. It was all provided externally, either because there were pure functions or widgets that had no logic inside. But imagine we want to test something more complex. Something like a widget that loads a list of items from a server and then displays it. In the app, we have the homepage, a widget that loads a list of gifs from the server, which uses internally the API service class to load this data, and then displays it using a feature builder. We don't want to use the real API service here, but instead we need to provide one that returns a fake response so we can control and test these results. In summary, we face two problems. We need a way to pass an API service that we can control, and we need a way to create this fake API service in some way. So to solve the first problem, we are going to use old good dependency injection. For the second problem, we need to decide if we are going to use a fake or a mock. So let's look at these solutions. As I said before, one problem is that the classes and methods you want to test depend on other components that can't be tested. The solution usually boils down on being able to provide those dependencies externally. In my experience in Flutter, there are three different solutions. And I know people that use the three together in the project. Others like me prefer to stick, for example, to just constructor and provider. So it is up to you. Constructor means that we pass the dependencies per parameter. Provider is a way to pass dependencies down the widget tree, which also has a lot of other cool features. And get it is another way to provide dependencies that does not depend on the build context, so that helps in other cases. Dependency injection per constructor is the easiest one, and the one I will always recommend as the first option. For example, here, this use case class needs a service, and we pass it as a constructor parameter. Then in our test, we are able to pass this fake API service that we have created instead of the real one. And I will explain how to create a fake API service very soon. In other cases, we may need to pass dependencies down the widget tree. For example, we want to make this API service available for the widgets in the app. With provider, I can define a provider that wraps the whole material app, and now all the widgets inside my app can access to it by calling provider off. In this case, I pass a real API service when I'm running the app from my app.dart file. Then, when I'm testing my widgets, I can provide a fake API service to the widget that I'm testing. So I can use provider directly in my test to provide dependencies that I can control. When it comes to state management, my answer is clear. Use whatever allows you to test your code, whatever allows you to provide dependencies and to make your code easy to test. If you see any state management solution that doesn't include easy testability in their features, I will personally avoid it. I like to keep things very simple. And so if you can just go with provider, then you don't need anything else. Once we know how we can pass dependencies to our widgets and classes, let's see how we can create fake dependencies that can be tested. We mainly have two options here, fakes and mocks. So what's the difference between these two? They both serve similar purposes, but the main difference is how they are made. A fake is a custom implementation of a class that fakes its functionality. For example, by always returning true or a hard-code list of items. A mock instead is a special object that mimics the mock class and provides a series of methods that allow you to configure in real-time answers to method calls, capture calling parameters, and as well to verify if those were actually made or not. This is an example of a fake API service. Usually what you want to do is to implement the implicit interface that the class has always. So in Dart, all classes have an implicit interface that you can always implement. And then you override it. While you override these methods, you will have to with hardcode values. The good thing is that it does not require any special library. You can just create this class on the same test file and you can just use it. No external dependencies. Then for using it in a test, you do it as before, providing the fake directly to the widget. We can run this test and it will say that it works as expected. To use mocks, we will need first to add the Mockito library for Dart that you can find on pub.dev. And then we need to do these two things first. First, create a class that is called mock API service that should extend the mock class, which comes from Mockito, and implement the interface of the API service that we saw before. Then create an instance of this class. And then you need to call to this when method to mock a special answer for the call getGifts. In this case, we are answering also a hard-coded list of GIFs. The power here is that we can change the answers depending on the test that we are. So we can create one mock and then you can keep changing the when answer, depending on the parameter, depending on whatever, on the test that you are. While on a fake, it is harder to configure different responses. So you will have to create your fake in a way that it can be configured. That's extra work. Similar as before, we pass the mock to the widget using provider, and the test works also as expected. But also here we can use one of the features from Mockito and we can verify that the method getGifts was actually called. And it will fail if it was not called. With this method, we can do things like verify that it was called 6 times or verify that it was never called. So which one will you pick? The biggest difference is that fakes do not require any external libraries to work, while mocks require you to add Mockito to your dependencies, which maybe in an external project that you are collaborating with, you are not allowed to do that. Fakes are also easier to write, in my opinion. The when then answer API from Mockito can be a little bit confusing, while fakes are, well, just implements an interface and overwrite everything. However, mocks provide also extra functionality that you can have in a fake, but it requires extra work. So which one would you pick? I personally use both because sometimes a fake is simpler for what I'm trying to do, and sometimes I actually need a mock, and then I will use Mockito in that case. So I use both in my projects. With that, what you have seen, you know already enough about testing in Flutter that you can start to have a clear idea on how much we developers can cover one app with widgets and with tests, sorry. But the question remains, how many tests should I have in my app? What's the ideal coverage here? I want to talk a little bit about the test pyramid and how it compares to Flutter. This is a simplified version of the test pyramid as it appears on the blog post by Google called Just Say No More End-to-End Tests. And you have the link also there. The idea is that in an app, the bulk of your tests are unit tests, which are the base of this pyramid. Then you have less integration tests, and finally you have few, if any, end-to-end tests. So what do we understand by unit tests? Those are tests that are small, that take a small piece of code and test it in isolation. They are great because they run fast, they are usually very stable, and they help you to isolate issues in your code. Integration tests go one step extra and take a bunch of those smaller units and verify that they work together. Their power is by verifying that the different parts work together, but you maybe still don't have the full picture. And definitely you are not simulating what the real user is doing. And this is where end-to-end tests come. They actually take a real app, build it, and run tests on top of it. So Google suggests a 70-20-10% split. And this is not for Flutter. This is just in general from that blog post. And it says 70% unit test, 20% integration tests, and 10% end-to-end tests. So you might be tempted to think that, well, Flutter driver are end-to-end tests, widget tests are integration tests, and Dart tests are unit tests. So I will just follow the 70-20-10% that Miguel just told me in this talk. No, it doesn't really work like that. So in my opinion, it's different. For me, it is something more like this. You don't want to have a lot of Flutter driver tests because they are slow and they are hard to write and to maintain. What I understand as integration test is in fact complex Dart and widget tests that connect two or more components of your app. For example, you can have a complex widget test that performs navigation and goes through a whole registration process, or maybe purchasing an item. You test many widgets at the same time, many different screens, the integration with your use cases, etc. And then you can also have unit tests, both as pure Dart tests that verify the functionality of one function, or a widget test that verifies the functionality of a single widget. And those for me are also unit tests. And actually, I disagree with the Flutter documentation that calls Dart tests unit test, calls Flutter widget tests, and uses integration tests to refer to Flutter driver. In my opinion, here the Flutter documentation is contradicting what Google said on that blog post. So with a definition of what an integration test is. The main idea I want to share is that you should treat widget tests as unit tests and write as many of them as you can. Another concept you should be aware of is coverage. This is the percentage of lines of code that are being executed when the tests run. Both Dart and Flutter tests share the same code coverage statistics, so both will be considered when counting code coverage. On the contrary, as far as I know, there is no easy way to evaluate the coverage of driver tests. To generate the coverage reports, run Flutter tests with the option coverage. And this will generate a file called lcov.info inside your coverage folder. If you open it, you will see that it contains some weird data that doesn't really tell us what's the actual coverage. For that, we need to use a tool called lcov. By running this tool called lcov, you can install it on Mac or Linux. There are some options in it, like the summary that will display a quick summary showing the percentage of lines that are being covered by the test, or the option -L that gives you detailed info for each one of the files and the percentage for this file. And then also it is compatible with Code.io. So you can use advanced tools like this one to track the coverage of your projects. For example, here, this is from a real project, and this is an integration with CI. And you can check, I can check there in my PR, the code coverage, and well, this is from a real project that I'm working with. So it works really well. My recommendation to everyone is to aim for 70% on average for an app. If you're writing a library, it's a different story, but for a normal Flutter app, my experience is having 70% is an excellent number already. So to end, I would like to talk about some edge cases that testing in Flutter has and that you should be aware of. It's time to talk about these mock network images for that you saw during the talk. We have seen that we need to add mock network images for to our test. And as you can guess, the reason is because we have network images in our widgets. Our GIF score widget has an image network widget in it. If we run the test without that, then we get an HTTP exception. Exactly what we get is the HTTP error 400. The reason is because the Flutter testing framework creates a fake HTTP client that always returns 400 for calls, including also image network requests. They decided to do this because they argue that networking inside tests is a bad idea, and I agree with that. And since network calls depend on external factors like connectivity to the server not being down. But you could in fact override this HTTP client and to return something else. That's what we are doing in this mock network images for. In my project, I'm using a little package that implements it. It is called network image for mock. What this package is doing is to override the HTTP client and use Mockito to provide an empty image when there's any HTTP call happening. And in this case, when the image network widget is requesting an image. Another thing to keep in mind with widget testing is how we deal with animations. Imagine that you have some button that once is clicked, an animation plays. If you simply create your test in a way that you tap the button and then you want to check if the test passed or not, it will not work because the widget tester is not rebuilding and advancing the clock automatically for you. So you have to do two options here. One is to call tester pump with a duration. And this duration can be, for example, your animation length, and that's rebuilding until that time has passed. Or you can call to pump and settle. And this repeats the pump call until there are no more changes happening. We say that you should not do network calls on widget tests, but actually, if you want, you can do network calls on Dart tests. For example, you can use them to verify that the server is responding correctly to your HTTP calls. Those are usually have them ignored by setting the skip parameter to true and run them only when I refactor my HTTP code or my API parsing functionality. So I don't run them every time on CI. But yes, you can have also async code on your Dart tests. So you can wait for responses. You can do async code without problems. What happens when you don't control the async call and you need to return a feature or something else? You may have noticed that I've been using in the project this synchronous feature class, which is provided by the Flutter framework. This is a fake feature that returns immediately. And this allows you to write asynchronous responses that originally returned a feature that won't depend on asynchronous code running on the test, but rather immediately return this value. And finally, I want to show you a couple of new ways of testing that the Flutter team is also working on. One is called integration tests, and which allows you to run Flutter widget tests on a real device. This combines the power of the widget tester API with the ability to run on a real device and being able to use the real device functionality. There are some Flutter plugins from the Flutter team that use this. solution for testing. For example, the Android Intents package uses this in the test. And the best part is that they explain how to integrate it with Firebase Test Lab to run those tests in the cloud. There's also Espresso, which is a more experimental one that allows you to call into Flutter from Espresso tests. So from Android code, you are calling into Flutter. Not that I would recommend you to ever do that, but actually cool that an API exists for that. A quick recap before I finish. The most important concepts that you have learned today. We mainly have three different ways of writing tests in Flutter. Plain Dart tests, widget tests, and Flutter driver. Plain Dart tests are fast and reliable, but you cannot test widgets with them. Widget tests instead allow you to test your widgets, although they come with small limitations. And Flutter driver, which runs on a real device, is the closest to a real user, but they are hard to write and hard to maintain. Plus, they are also very slow. Your app architecture is very important. You need a way to provide dependencies externally so they can be mocked, and also understanding how to create fakes and mocks is an important part of testing. And with this, we reach the end of the talk, and thanks a lot for listening. All right, so let's answer some questions. Can you also perform tests on native code embedded in Flutter? For example, unit tests, business logic, embedded native UI elements. So I think that the biggest example of these are the Flutter framework project and the plugins that they have. They are in fact using this integration test and this Espresso library to, for example, if you want to test Android code or platform code or a platform channel, for example, you need to use a real device, and you need to use the device that you want to test the native code for, and you need to do a Flutter driver test. So the integration test package that the Flutter team has created to test these cases is the most effective way to do that. And what I will do is, if you have native code that you need to test, is don't have that in your main project, but create a platform plugin. And then in the platform plugin, you should write a test there. So you can test everything in isolation instead of having that inside your app. It's an architecture problem. I mean, it's quite complicated, but you should follow what the Flutter team is doing in these cases. Thanks a lot for the very interesting talk. And I like that you like this talk. It was a new talk, so I hope that you like it.